Hi, I'm Professor Mike Wood. I'm Professor of Applied Ecology at the University of Salford in the UK. Over the last 2 decades, I've been working extensively on environmental radioactivity research, including work on radiation measurement, dose assessment, and also studying the effects of radiation on wildlife. I've also undertaken extensive work within the Chernobyl exclusion zone since 2013. And in this talk, I'm going to explain about some of our research that we've undertaken on reported elevations in gamma dose rates within Chernobyl. Following the Russian military's invasion of the Chernobyl exclusion zone area on the 24th of February 2022, there were reports of increased gamma dose rates from the monitoring network, which is distributed throughout the exclusion zone. Those elevated dose rates that were reported were still within the range of dose rates that are typical of the zone, but conventional and indeed social media went into a reporting frenzy, speculating on the reason or reasons for the increase. Some suggested a leak from the Chernobyl nuclear power plant complex, undoubtedly their minds turning back to 1986 and imagining a kind of Chernobyl 2 type situation. Others took a more measured approach. The State Nuclear Regulatory Inspectorate of Ukraine and subsequently the United Nations International Atomic Energy Agency had reported that heavy military vehicles resuspending contaminated soil were a potential explanation for the increased dose rates. This hypothesis made intuitive sense. We know heavy vehicle movements can resuspend material from the ground surface, as you see in this photograph here. We also know that deposition from the Chernobyl accident left a soil contamination legacy throughout the zone. The hypothesis that radiation spikes were due to heavy vehicle movements resuspending contaminated soil was widely reported. It was reported by the BBC News, by Forbes, also by New Scientist. I even gave an interview myself for LBC Radio in the UK on the 25th of February, saying that this hypothesis seemed likely. I was conscious that the hypothesis needed to be tested, and also that my Ukrainian scientific colleagues had other priorities to focus on. As you may be aware, I work very closely with Professor Nick Beresford from UKCEH. Nick and I discussed the elevated dose rates and did some rough calculations. These rough calculations suggested that soil remobilization was unlikely the cause of the elevated dose rates. We therefore enlisted the help of Pete Burgess, who is an exceptional radiation metrologist. We also enlisted the help of Shelley Mobbs and Kath Barnett, two of our other UK-based colleagues who specialise in environmental radioactivity. We started by gathering data on the gamma dose rate baseline and the extent of the spikes in dose rates that had been recorded by the gamma detector network. The network consists of 67 detectors at locations across the exclusion zone, including a few outside of the exclusion zone. One of those is at Slavutic. The detectors are understood to have self-contained battery power units enabling continuous gamma dose rate monitoring and wireless data transmission of dose rate readings through to a base station in Chernobyl. The detector network is operated by the State Specialised Enterprise Eco Centre, and data are accessible via a web portal. Unfortunately, when we came to trying to access the data for the purposes of this analysis that I'm presenting here, the EcoCentre web portal was no longer operational. Thankfully, we were able to extract the data from saveecobot.com for an approximately 14-day window from the 17th of February to the 2nd of March 2022. One detector seemed to have been offline since May 2021, so we were actually able to collate data for 66 detectors that had been operational within the network during the period of the Russian invasion. Here you see some of the pre-invasion baseline data overlaid onto a deposition map for the zone. We investigated both the absolute dose rate measurements and also the ratio between the peak dose rate recorded and the baseline. 39 of the 66 operational detectors had reported spikes in dose rate. On the left of this slide, you see the peak to baseline dose rate ratio for detectors that reported spikes in gamma dose rates on the 24th of February. And on the right, you see this for detectors that reported spikes on the 25th of February. For detectors reporting spikes on both dates, the spikes on the latter date, on the 25th of February, were consistently higher than those on the 24th. After the spike dose rate, 30 detectors went offline immediately. The remaining 9 detectors rapidly returned to the baseline dose rate reading. And I mean, when I say rapidly, I'm meaning within 30 minutes to 3 hours, they were back at the baseline dose rate measurements before they also went offline. The highest peak to baseline ratio reported was for this detector, indicated with that red circle. This detector is located to the east of the Pripyat River. It's approximately 30 kilometers southeast of the Chornobyl nuclear power plant complex. The peak dose rate was 576 times higher than the baseline. This equated to a dose rate increase of 60 microsieverts per hour. This location's along a minor road which only provides access to this and one other location. There is therefore no logical explanation as to why there would have been significant military activity at this site. The detectors that reported peak dose rates, these increased dose rates, were interspersed with detectors that continued to report baseline dose rates. If you look at this figure in front of you, you can see a single solitary black triangle which indicates the detector that was offline throughout the entire period and had been offline since May 2021. The orange triangles indicate locations where detectors peaked. The green triangles indicate locations where detectors stayed at baseline levels. As you can see, there was no logical pattern in the dose rate peaks. There was also no pattern that seemed to coincide with obvious transport routes. We also noted that the weather throughout the period of the elevated dose rate readings was very stable, with minimal wind to carry either resuspended soil or contaminated material released from the Chornobyl nuclear power plant complex over any significant distance. Coupled with the lack of spatial pattern in the detectors that did report dose rate spikes, this indicated that neither a leak nor contaminated soil resuspension were plausible explanations. We also noted that 55 of the detectors actually came back online between the 28th of February and the 2nd of March 2022. And for all of those detectors that came back online, the reported gamma dose rates had returned to normal baseline levels. So although the data did not support a soil resuspension hypothesis, we did want to determine whether the kind of peak to baseline ratios for the gamma dose rates that had been reported by the detectors could even theoretically be achieved by resuspending contaminated soil. The modelling approach that we developed is described in detail in the paper that I'm going to provide you with a link to later in this presentation. Briefly, we calculated the contribution of gamma photons to the detector measurement up to a radius of 50 meters from the detector, accounting for attenuation both within the soil and in the air. Based on limited soil core data that were available, we assumed the profile of the gamma emitting radionuclides in the soil to be biased towards the upper levels. So the majority of the gamma emitting radionuclides were assumed to be within the top 0 to 5 centimeters of the soil profile. We then made a series of highly conservative, i.e. peak to baseline dose rate maximizing assumptions. For example, we assumed that the entirety of the top 3 centimeters of soil was resuspended into the air and uniformly distributed up to a height of 2 meters, but also, conservatively, that there was no photon attenuation by the soil once it had been suspended in air. As well as modelling the potential change in gamma dose rate measurements for a detector mounted over bare soil, we also repeated this modelling for a detector mounted over a concrete plinth extending up to 2 meters radius. Even with the most conservative assumptions, soil resuspension could not explain more than a factor of approximately 3 increase in the detector readings based on the modelling that we undertook. Clearly, this is far lower than the observed peak to baseline dose rate ratio of, well, the maximum being 576, and indeed the lower ratios were generally significantly above that ratio of 3. So, following the Socratic method of hypothesis elimination, we've demonstrated that the increased gamma dose rates cannot plausibly be explained by contaminated soil resuspension or contamination released from the Chornobyl nuclear power plant complex. If those two hypotheses are eliminated, how else could the increased gamma dose rate be explained? Well, here we formulated an alternative hypothesis, namely that electromagnetic radiation from military activities may be the cause. The lack of spatial pattern makes it unlikely that electromagnetic radiation, for example from radar scans, is disrupting the operation of gamma detectors directly. If that was the case, we'd expect neighbouring detectors to be similarly affected. Perhaps more plausibly, the electromagnetic radiation or other interference from military activities may be impacting on the reception and or processing by the Chernobyl base station of data being transmitted from the wireless gamma detector network. New Scientist magazine which, if you remember, had previously reported that the radiation spikes were likely due to soil resuspension, subsequently reported on our findings and this hypothesis in mid-April. However, the electromagnetic radiation explanation is a hypothesis. It's a hypothesis that needs robust testing. And I hope that this presentation may help to foster collaboration with Ukrainian scientific colleagues who have detailed knowledge of the gamma detector network in Chernobyl, including the wireless communication protocols and the data processing by the Chernobyl base station. As the zone gradually opens up and it's possible to restart field research within the Chernobyl exclusion zone, we can hopefully find ways to test this hypothesis together. Being able to definitively explain what happened and why is important. It's important to ensure confidence in the gamma dose rate monitoring network, and that's important from a public reassurance perspective. It's also important because this network is a core part of the international safeguards for nuclear sites. We also mustn't lose sight of the importance of robust science clearly communicated from the perspective of public communication. As someone who's passionate about science communication, especially in relation to Chernobyl, radiation and radiation risk, I'm acutely aware of the need for clear and effective communication based on robust science. There is a real danger that misinformation and uncritical media reporting of the radiological situation in Chernobyl will rapidly undo much of the good work that so many of us have undertaken over recent years to dispel myths and ensure that the public start to understand scientific reality. However, radiophobia is easily resurrected, and that's illustrated by the surge of public interest in reports suggesting, for example, that Russian personnel developed acute radiation syndrome because they dug trenches in the Red Forest soil. From a radiological perspective, that makes no sense, but these suggestions play to a part of the human psyche that seems to easily accept myth over science. The Chernobyl exclusion zone provides a unique and globally important natural laboratory for radiation research. I sincerely hope that I will be able to return to Ukraine very soon, re-establishing and also developing new international collaborations with the many exceptional researchers within the Ukrainian scientific community, and working together to deliver robust science that can subsequently inform public education and communication, whether that be at the level of local communities or through discussions directly with government representatives. I hope you found some of those thoughts, reflections and explanations of interest and of use. Thank you for listening.